I'm Michael Demey. I'm the research manager at iText, and I lead a small team responsible for innovation and standardization within iText. That means that we write prototypes who look at existing technologies, new technologies, and other products to innovate and leverage iText. We do standardization work as well, so we are members of ISO, we vote on resolutions and new comments and stuff like that, and we also contribute for the PDF Association, as you can see today. Next to that, my team is also responsible for developer marketing, so we write up articles, we go to conferences, we go talk, as like today. They also mentioned that I should be more on social media, so I took that as I should post PDF memes on Twitter. I also post serious content, I should say that from my marketing manager. Next to that, I'm a father of two. I've got a young boy and a young girl. They're the highlight of my day if I'm not working with PDF. They're just the best. And next to that, I'm also very enthusiastic about playing bass. So I play electric bass, but more importantly, for me at least, not for you, I play the upright bass, I play double bass, I play tango, and I play classical music. So if you want to follow me on Twitter, that's my handle right there. If you want to see the memes, pick the first one. If you want to see the more serious content, pick the second one. It's up to you. We'll let the audience decide. So let's get the introductions. Let's dive a bit more deeper into the introductions. I need to position iText as well because it might be a bit, let's just frame what iText is for you guys. So iText is an open source PDF library. We have written an SDK like 20 years ago. We've been updating it ever since. We're on our 7th version right now. And we create PDF files. So we let developers create PDF files and let them manipulate them, sign them, do text extraction on them. Anything that you want to do with an SDK, it's probably going to be there. And if it's not, yeah, you can either do a pull request or a feature request. We'll see what we can do. So it's on GitHub. Feel free to check it out. It's open source in Java and .NET. So with the introductions out of the way this time, why should you test documents? Well, documents are frequently public-facing. So you send out files to your customers, you send out files to anyone that may want to read them. I'm thinking about recently, the governments, they've been sending out corona measures that have been taken. Some of those have been PDF files, the forms that you all had to fill out throughout the past 2 years for the PLFs, the passenger locator forms. Those are most likely in PDF. So you need to have the trust that your documents are consistent, that they do what they need to do, and that everyone can open them and see what they need to see and fill out what they need to fill out. So your public-facing documents are sort of a representation of what your company stands for, and you need to have that consistency and that reliability out there at least. There's more reasons to it why you should test documents. So security is a big concern as well. You don't want to be, but that's more on the input side. Like for us, if we parse a document, you don't want to be vulnerable to zip bombs, basically. Or nobody wants to be vulnerable to that, let's be honest. If you send out PDF files, you want to be compatible with multiple vendors. If we send out a PDF file, we don't have a viewer, so we need to take into account different types of viewers. And as we all know, viewers don't agree with one another. So you need to make sure that you are compatible to that. You try to be compliant to the spec, but as we also all know, nobody's really fully compliant to the spec, unfortunately. But we still try. So we try to be as compliant when we write files and as lenient as we take in files, but that comes with a cost at some point. And thirdly, we also want to test for, to avoid regression. So regression is basically if you update your code, if you update your program, and your functionality gets worse, you want to capture that. If you change a certain feature in your SDK library, and suddenly all the colors that used to be red turn blue, that's a problem, right? It's a very extreme. It shouldn't happen, but you never know. So we want to avoid regression so that you have the consistency still available. So what needs to be tested? There's more than just the visual stuff on there, but the visual stuff is very important because PDF in its essence is also a visual document. But you want to test the functional requirements. I was talking about the PLFs before, so you want to make sure that your forms are fillable, that they are not just flat forms. We want to do visual requirements that they still look the same, that they still look decent and are openable in multiple platforms. You want to do processing on our side at least. If you take in multiple files from multiple vendors, you want to make sure that everything processes correctly. The rendering, we don't do so much rendering, so it's not going to be heavily featured in this talk, but if you render, you want to be consistent across documents, across vendors that you pull in. And then the more important one is leniency. As I make the comparison to HTML, because HTML and browse, they try to be very lenient on HTML files just so that you can expound on the user experience. You don't want the user to suddenly have a bad experience because you don't know how to handle a certain type of input. So HTML tries to work around that, and as we all know, PDF viewers also try to work around that. So as I said, try to be strict when going out, but very lenient when going in. So today I've split up this talk in like 2 sections, big sections. First, we'll talk about 5 strategies on how to tackle testing of files, and more specifically PDF files. And next to that, I'll give you guys a sneak peek into what my team has been doing and show you some prototypes that are a bit more, what's the word, zany, a bit more out there. Yeah, unorthodox is maybe the word. Does this work? No, it doesn't. Okay, they should have tested that. Okay. So all these strategies are strategies that iText at one point has put in place or moved away from. So it'll be sort of a bit like the history of iText as well. So I'll just refer back to how iText used to do it and how we do it now. But every method is a valid method. There are valid use cases for all the stuff that we are going to talk about. And the first one that we're going to see is manual testing. So what do I mean by manual testing? I'll give you a very, very real-world example based on iText. Back in the day before we were an actual company, so the company was founded in 2008, the product in 2000. The testing happened manually. Every time we did a release, we had you could call it a test suite of tests that if you ran them, files came out, PDF files. And what would happen is that at the time, Bruno, the founder of iText, he would take the files from the last version and the files from the new version, and he would compare them. Have they improved? Good. Have they not gotten better? Even better. So, gotten worse, sorry. Even better. So it was a very tedious manual process. This could take up to a week even. So if we decided on a release back then, we had a code freeze. We would go through all the tests manually. If there was any bugs, we had to go back, stuff like that. It's very cumbersome. The downside to that, it's slow because you have to go through every file that you have. And yeah, it looks okay. Doesn't mean that it's okay. Like sometimes, for instance, Java just did it, right? They changed how floating point works in one of the latest versions. And if you're off by just the tiniest fraction, even though it might look okay, it can't, like, you could be on screen that it's not really okay if you look at the exact coordinates and the exact curves, for instance. But it does give you a large sense of control because you are looking at the files, you are looking at the exact things that you want to test. And the testing is immediate. You do it right when you do the release, for instance. And one of the cons, one of the biggest ones, is largely dependent on whoever is testing. You might have the strict thorough guys going through every file as they should, looking at even the content stream syntax, or you might just have the intern that's like, okay, the files are about the same size. That didn't happen, but so it's largely dependent on whoever is testing, but also if you switch between 2 versions, between PDF viewer software, if you, for instance, use Acrobat for version 1, but you use Foxit for version 2, there might be a huge difference between the two, even between versions of certain software versions. So it's largely dependent. So that's all to say, can be a bit hard. So that's a bit what you're trying to do, the graphic. But it's good for single releases, small projects. If you have 10 files, nobody cares. But if you have thousands of files, you don't want to spend basically weeks doing that. And that's what iText also did. We moved away from that, at least in the automated build testing. So I want to introduce the metrics matrix. So this is Michael's matrix. Well, if you can say that 10 times at our booth, we'll give you a business card. So on the left-hand side, you can see the manual strategy, all the strategies that we're going to talk about. There's 5 today. And then there are the few different categories that we have seen, a few different aspects of testing. So there's investment, which is how many resources do you need to throw against this? I'm talking about man hours or person hours, architecture, software that you need to get. So in this case, it's rather low, with the caveat that you need to throw a lot of person hours against it if you have a large corpus to test, of course. There's a difference between 10 files and 10,000 files. The ease of use is how complex this strategy is to use. How complex is it to implement in your organization? How complex is it to get up and running? In this case, it's very easy. The ease of, no, it's very high. Excuse me. It's very low because there's so many things to look at, and you need to basically train somebody to do it. It's not automated, first of all. It's all very manual. The maintainability talks about how easy it is to upgrade your files if something new's changed and stuff like that. In this case, it's very low. Could be higher, could be more automated, could be more manageable. Then the fifth column is coverage per test. So that talks about how well a single test is able to cover your code, to cover your use case. And in this case, it's medium depending on what you're looking for. If you're only interested in rendering, then just looking at them in viewers is going to be okay. But if you have to open, for instance, iText RUPS, which is a PDF inspection tool that we use to look at the actual structure of the file, then it's going to be a bit harder. It's going to be more tedious. And the coverage is going to be a bit more annoying to track as well. The focus, by that we mean that and every time you write a test, every time you try to test something, there is a feature that you want to look at. There is an aspect of a PDF file that you want to test, and either you are focused or you're not. You zoom in on the single thing that you want to test, or you just take the whole file and you ignore basically, or you take everything into account. And in this case, you can get very focused. Like you can use any PDF inspection tool that you find, and you can look at the exact bytes that you need. And then we try to give it a ranking on performance. As you can see, it's so this will be dead last in the ranking. So we moved from manual to automatic visual testing. So it's basically the same. So we have a reference file this time, and we have code samples. The code samples describe what you're trying to test, and outcomes PDF file. The reference file is what it should look like both visually and structurally. So the pros are it's very performant. You can at least compare it to the manual stuff. So you can quickly get a very big corpus to test out your files, to test out your code, and gives you a very broad visual coverage. I forgot to mention, actually. So you have the reference file and the file that comes out of your testing. And what we do in that case is that we convert those to images. And then we compare those images to each other. We do that using GhostScript, which is also an open source library, and we compare them, the images together. There's a few downsides to it. First of all, I don't like it. Secondly, you're not testing the structure of the PDF file. You're just testing the visual aspect of the PDF file. You're not testing, for instance, if your dictionaries in your PDF files are correct, if you included the font files correctly and stuff like that. So you're overlooking a whole section of a PDF just because it's convenient. That's not to say it's not necessary, but it's not testing completely. If you have a lot of tests and you change something very basic in your PDF generation, for instance, you change the way that you handle certain things like the margins or the padding in your tables or in your paragraphs. And if you change that, then all your reference files need to be changed, even though a certain test didn't even test for paragraphs, but it just wanted to see an image or a color that has changed in the text. So there's very little focus in that kind of testing. And if you look at a singular file, a singular test, and if it fails, you have to dive into the PDF file. You need to know what to look for. You need to look at error logs. You need to look at multiple aspects of the PDF. You have no real way of knowing why a certain reference file failed this time. So that's the tagline I liked, right? Good when you want to test, when you want your test to cover a lot visually in a short time. And that's what we did as well. So it's easy to ramp up, right? You write your code, out comes the reference file, and then you test against that as well. I'd have to say one of the more annoying things is when you have to change a lot of files, because you don't want to do a blanket replace all for all your files if something new changed, because if you have 1,000 files that all have to be changed, I guarantee you there's going to be a few edge cases in there that, that you don't want to automatically update. So placing that in the matrix, so the investment is medium. You need to set up the technology stack, even though it's not that complex, but I would rate it higher than the manual testing. The ease of use is very high. In our case, we called them compare tests on a visual level. They are generated within minutes. That's just easy to do. The maintainability is average. Depending on how you deal with replacing files that should be updated, like your reference files, you need to update them, of course, once every, depending on what you change. The coverage per test is pretty high. In our case, if you would run a test for a simple feature, the entire iText, you're basically testing the entire iText stack against your reference file. So the coverage per test was pretty high, even though the focus was pretty low. So it's all about statistics, right? The performance is a bit better. That depends, of course, on your testing size. If you have loads of documents, it's going to be slow, but it's never going to be as slow as having a guy in the back office doing it all. Then we move on to a bit more intelligent testing. So we compare against a reference file. That's the automatic or automated structural testing. So you go through the PDF tree and you look at the dictionaries, you look at the arrays that you find through the files, the embedded files, and you look at the content of them. PDF doesn't specify an order in the dictionaries, doesn't specify an order in the actual file itself. So the objects shouldn't be ordered, let's say. So you don't want to test the structure for order because that's irrelevant. At least in this case, there are use cases where that's valid, but yeah, not in most cases for us here. So that allows for differences in order structure-wise. So a PDF file may look the same, like two PDF files may look the same, but have completely different structure behind the scenes. And depending on what you want to test, you don't want to change the structure too much. Or you don't want to change the visual stuff, depending. It's very quick. It's quicker than converting them all to images and then testing them because you just go through the PDF stack that we have. So you just use iText to extract everything. As mentioned, it's very precise because you look at the content of the actual dictionaries and you compare them. The cons are pretty much the same as the previous cons, so there's no way of knowing if a test fails. I would say you could basically, figure it out a bit more logically, but yeah, it's a bit more effort to do that. And it breaks easily for the same reasons, but even more so because you're looking at the structure and not just the visual stuff. So good when you want to test, when you want your test to cover a lot structurally in a short time. So it's basically the same thing as before, but a bit more intelligent. So as you can see, we put that into the matrix in a very similar manner. So investment, ease of use, coverage, and focus are about the same. Maintainability is a bit lower because you do need to have a bit more development work done if something changes. And it's a bit more performant than the automatic visual stuff. So this is a bit the naive step of doing comparisons. I mean, I think this is where everyone who has ever done PDF testing starts off at, I think. You can't compare the entire files because there's some stuff that does change, like the creation date of the file, but you can basically compare the output of your SDK or the input of whatever you have against the reference file, just byte by byte. The pros, it's very quick. You don't need to do any PDF processing. You just go at it. It's very precise. I mean, yeah, you're comparing bytes. The cons is it's very inflexible, so it's very rigid. You don't want to do this, basically. Well, in some cases you might, but I can imagine some use cases where it would be valid, like in governments or high secure environments that need to have like very specific requirements on the files. You may want to use these kinds of tests in some kind of way. And it's extremely fragile. I imagine if we would use that today, I think half of our development team would quit. So best not to use that, I would say. So yeah, so when maintenance is not an issue, basically. I keep forgetting that these pop up. Okay. So placing that into the matrix, we first of all get the performance of 1. It's our first ranking performance toolbox thing that we have. Not surprisingly. The focus is very low because, yeah, you're just testing bytes. The coverage per test is pretty high. You're testing the entire file, so that's good. But the maintainability and the investments is off the charts. You don't want to do this at all. But yeah, given the caveat I just mentioned. And this is the more interesting one. This is the one that has my preference, to be honest. It's one I try to push within iText itself. Get a drink. So aspect-based is basically testing PDF files for certain stuff that's in there, testing for features. I always compare it to a, well, at least mentally. I think it's the first time I'm going to say it publicly, but so I compare it to a surgeon who cuts open a stomach and moves past the infected stomach and pushes away the spleen that's way too big to cut out a piece of the liver. So you're very focused on whatever you want to test. You don't care about all the other stuff that may or may not have gone bad. You care about the actual liver in this case. So you just go into the PDF file, you take what you need, you look at it, it's good, and then you close it, and then your test is basically good. It's very hard to do unit tests on PDF files. That's what it basically boils down to. So either you try to be focused, you try to zoom in on the PDF file and ignore everything else, or you do everything in one go. So it's very focused, it's quick because you only open the PDF file partially, you only look at a certain part of the PDF file. And depending on what you test, of course, you can handle changes in layout and structure if you, of course, handle navigation to that part in the PDF file intelligently. The cons for this is that it takes a lot of time to create those files. You need to navigate all those files to the exact point in the PDF file to get the information out and then compare it. But it gives you the most benefit, I would say. So I forgot this line again. So it's good when you have time. We all have time, right? Okay, so placing that into the matrix. So you have the aspect-based one. So the investment is high. As mentioned, you need to write all the tests. You can't do an automated test creation like you could for the auto-structural or the auto-visual, where you just drop a file and out comes a comparison against the reference file. You need to write all those files, those test cases. In iText, we use a tool called Cucumber. I think it's also open source. Correct me if I'm wrong. And it uses a sort of abstracted away language. So you could write literally English or Dutch or French, whatever your language of choice or force is. But you could write certain test cases like, given this PDF file that I've signed, when I extract the font file, I should get this, basically. And that's just English. Behind the scenes, it translates to Java code, .NET code, whatever you want. But you need to hook up the English and the Java code together. So that's where the investment comes in. So that's a tool that we use. That's something that I would always recommend that you guys also use if you're developers. The ease of use is medium. There is some step into the get in there. Like there is a learning curve to it. Maintainability is high. Well, you can see it there. So low. The coverage per test is low because you are focused. As soon as you focus down on certain aspects of a PDF file, the coverage does go down a bit because you're focusing. And performance-wise, I would rate this the second one out of the pack. Because yeah, it's not looking at the entire file, it's not converting anything, so it's just looking at certain aspects. So At iText, we use a combination of all of these. So I've expressed my preference for certain ones, and I've expressed my disgust at others. But it's always good to use a combination of all of them. So yeah, that's where it is. So my preference goes out to the aspect-based one. You could have valid use cases for other ones, but make sure to know that there's no one true and no one bad one. With that out of the way, let's go to the unconventional stuff, the stuff that I love doing. So there's a few POCs that we have on the slides, and there's more. So if we don't get to all of them, feel free to grab me at the exhibition floor, because I love talking about this, and the previous stuff, of course, as well. So introducing pdfScannerizer. It does what it says on the tin. It turns a PDF, a smart PDF that has text, that has searchable elements, interactive elements, and it turns them into a scanned PDF file, right? That's awesome. So it even includes the dirty scanner hair. You know, whenever you take a scanner, there's always this stray hair that you can't seem to get off. I even had options to allow for dirty coffee mug stains or like dirt. And this basically degrades the quality of the PDF with various options. Even like you could scale down the resolution. You could like rotate and skew the image because the image is never really perfect on the scanner, stuff like that. All the annoyances now automated for you. So why would you do that, right? I mean, that's crazy. Because we looked at OCR engines. We wanted to benchmark OCR engines. And when we initially started looking at open source engines, for instance, to use, our workflow was that we would have a bunch of images and somebody would transcribe the interesting ones. So they would write down all the text in a text file, and then we would push all the images through the OCR engine, out comes text, and then we compare. So we compare how far the distance is between two pieces of text. There's algorithms for that. The only one that comes to mind right now is Levenstein, but there's more. So it was a bit of a hassle, especially since we looked at multiple engines. You want to do that a bit more intelligently. So that's why I made this workflow. So we started out in HTML files. So we have somebody create an HTML file with art and stuff like that. I'm not a designer. And we convert that to a scanned image, scanned PDF file. So the entire HTML file we convert to a scanned image. And then we convert that, and out comes a, does this thing have a pointer? No. Okay, and out comes text. An HTML, developers in the room will probably know that it's relatively easy to get out the text of an HTML file. So you could compare the text that you extract from the HTML file against the text that you get out, all in one automated go. So you could script this and get numbers while you're sleeping, basically. So that was fun. This was one of the more fun projects I did because it was a bit ridiculous. Another one that I love playing with is the Arlington Model. There's going to be a few talks on this throughout the next 2 days, so make sure to follow them. I think it's one of the more interesting developments in PDF recently. And it's a PDF association resource. You can check it out on GitHub. But what Arlington is that it's a set of machine-readable rules. So Peter White and the people of the association, they try to convert parts of the PDF specification into rules, like what kind of data is allowed in this dictionary, what kind of entries are required, and stuff like that. And that's all freely available on GitHub. It's under the PDF Association organization. You can find it easily there. So I wrote a prototype that converts those objects into Java objects. I didn't map them all onto singular objects. I just wrote like a converter. Like I had an Arlington record and an Arlington object, and then it reads in the TSV files automatically, so that at runtime you get the file, the objects generated. And I wrote a bit more so that you can validate dictionaries. So you could take a dictionary from PDF through iText, you give it to Arlington and to my Arlington PC at least, and it will tell you if it's valid or not and where it's going wrong. So that's, I think, very interesting. So that's a low cost of maintenance in the testing library, because you could automate all of that. there's some validation that's happening in your testing, use Arlington, because the rules are there. You can easily switch through versions like PDF1 versus PDF2, 1.7, et cetera, et cetera. And the fact that they are managed through the TSV files means that you don't have to manage the rules yourself, because Peter will do it. And I'm being yellow carded. Okay, that was quite dramatic. Okay, the second POC for Arlington that I have in mind, this is something that I'm willing to spend some time on in the future, but it's still like mulling about in my mind. It's more in line with what Cucumber does. So I foresee a POC that has like a baseline PDF that's very empty, just like the minimal stuff, so that it's sort of a skeleton. And then you would write some Arlington descriptions, like I need this dictionary with these values, and you know that they all comply to the rules because they are going through the Arlington stuff. And then that Arlington description would be automatically inserted into the PDF file. So you could just, on the fly, would be able to generate PDF files like that. Very customized, very convenient. Of course, it does require some PDF knowledge because you're actually writing PDF dictionaries, but hey, we're at the PDF day, so I can expect you to... You're in the right room at least, so I could expect you to know this. And then the final one, or the second to final one, because I remember one that I wanted to bring up as well, is content stream compilation between quotation marks, because it's not really compiled. Earlier this week, Duff was mentioning that we don't need the PDF police. Well, I was thinking in my mind, yeah, I'm sorry, but I wrote PDF cop like 2 years ago. And PDF cop is basically a grammar file. So a grammar file that defines the rules of the content stream, like which operators are allowed in which objects, and which objects are allowed in which state of the content stream. And that is, you can compile that into an abstract syntax tree, which is a data structure available in Java and stuff like that. So it's just a data tree, basically. And you can basically validate your content stream syntax against that. So that has not been made open source. I'm not sure what we're going to do with that, but the Arlington stuff, which I forgot to mention, is going to be made open source in the nearby future. So that allows, so the abstract syntax tree, the AST, allows for easy inspection of the tree, basically. And even for some optimization, if you want to. Okay, I still have like a few minutes, so maybe I can also mention that we have PDF units internally. We're not going to use that name, but it's an internal tool that we have developed, a POC, that has like the fluid API in mind. So like how the assertions work in, I think it's assert for JO or something like that. So you could say assert that dot document, you give it the file, has this dot has that. So it's basically just writing code in English, and it looks at the PDF file. Yeah, it's very last minute that I wanted to say this, but it's also something that you could look into the more aspect-based testing. So the conclusion is, the next slide. There isn't a best strategy. It's very much possible to combine all of them, and it's preferable as well, because you want to tackle PDF or testing for PDF from all angles, and you want to make sure that you cover all your grounds. Stuff that we didn't get time for is like consider GDPR as well, so the data protection regulation here at your test files. Something that we used to do is we looked at customer files, but we delete all of those. So that's something, if you do that, make sure to delete those files unless you get consent from them. Consider security, which we didn't get into that much. I only had 45 minutes. And consider different kind of tools and platforms. Test your own SDK by using other SDKs. Test your viewer by using other viewers, etc., etc. And that was my last slide, and I think also my last minute. Thank you.